Hi and welcome to this tutorial where I will demonstrate how to create an Autosar application model with Arctic Studio. So in this tutorial we will create an application model, and this is one step that is a part of the Autosar workflow. And for this we will use Artext, which is a textual language, and with that we will create SWCs, interfaces, ports, etc. But before we start, I want to say a couple of words on Autosar itself, and more specifically on the Autosar layered architecture, but also, as I mentioned, on the Autosar workflow and methodology, as these concepts are important to understand what we'll actually be doing later. On the highest abstraction level, Autosar architecture consists of three software layers, as shown on this picture. At the top we have the application layer, then we have the runtime environment, or also called the RTE, and then we have the basic software. We will today have a top-down approach, meaning that we will only work in the application layer. The Autosar workflow can be simplified into 4 steps, as you can see on this picture. The first 2 of these is the creation of the system itself. And today we will stick to the first part of this, which is the system model phase. And this means that we will be making software components. In later tutorials, we will also go on to instantiate these software components and make ECUs extracts, and then also to make the rest of the steps of the workflow. So let's have a look at the system that we will be modeling today. This system is actually taken from an example in the Autosar specification that describes the virtual function bus. If we have a look at the picture of the system, we can see that it describes car seat heating for the 2 front seats in a car. And this consists of a heating controller, or 2 heating controllers, one for each seat. We have the heating dial, and then we have a heating element. When inspecting this model a little closer, one realizes that the controllers, the heating elements, and the LEDs are actually the same kind of entities. So instead of creating several identical applications, we could simplify this model without actually changing its functionality. And this is how such an alternative model could look like. What we have done is replace the 2 controllers with only one that has the ability to control 2 seats. Regarding the dials and the heating elements, we still have 2 for each side, but these are now the same kind of application, only instantiated twice. In other words, when doing the system model in Arctic Studio, we actually only have to create one kind of SWC for the heating element, one kind of SWC for the LED, and one controller controlling 2 seats. So let's finally start Arctic Studio and get to work. I will use the workspace tutorial, and in this workspace I already have 2 projects open, and this is the boards and the core. Boards you wouldn't need yet, and actually not even core, but it's always good to have. The next step is to create a new Autosar project, which is done by right-clicking in the Autosar navigator and choosing ArcCore Autosar project. In this project we will call tutorial Artext, and this we do because we want to distinguish it from the ECU configuration project that we will be doing in a coming tutorial. We keep the rest of the standard setting and press next, and here we don't have to reference any other projects, so we'll just click finish. Now that we have our project, we can continue and create our first SWCD file, our first Artext file. We do that by right-clicking in the Autosar navigator again, choosing New, Other, and in the bottom we have Other again and Artext SWCD file. Or we can search for SWCD. We will call our file for heating controller. And we will put it in the package tutorial heating controller. To edit our file, we go to the navigator again and double click. And we will be prompted to add an Xtext nature to the project. As we continue now, I will mention some Autosar concepts that you might not be familiar with. Unfortunately, it is not within the scope of this tutorial for me to explain all of these concepts in detail. So before we continue, I would like to hint to a vast learning resource online, which is the Autosar documents. These are located at the webpage of Autosar, and there is a whole bunch of specifications for each release of Autosar. A great document to start with is, as I mentioned before, the virtual function bus description. If anything I say further on in this tutorial is unclear, search for it in this document. But back to our application, let's have a look again at the picture of the system we modeled earlier. We can see that the controller has 2 receiver ports for the seat switches. So let's start to write this down in our application. We start with creating a component application, and we name it heating controller type. We continue with adding ports, and we shall start with the 2 receiver ports, which is the seat switch left and seat switch right. And we write receiver and then name it. And when we use the auto completion here, we can see that we are missing something because all ports require or provide something. And this we haven't made yet. What we need for these ports is actually interfaces, so we need to create these 2. So just as we did before, we go to the Autosar navigator and right click, choose new, other, and the Artext SWCs file. We shall name this file interfaces, and we will put it in the package called tutorial interfaces. We could actually make the whole model in the same SWCs file, but it is good practice, and especially since models have a tendency to become massive, it is also more practical to divide things up a little bit. Let's open up the SWCs file, and we will declare an interface which will be of the type sender receiver, and we will call it seat switch status if. An interface needs data to work with, and on the modeling level, this data does not need to have a connection to a base data type. For our example, we will make an enumeration for on and off, and we will make the connection for the data types of it at a later stage. So now that we have defined our switch data enumeration, we can finish the sender receiver interface as well. With the sender receiver interface done, we can now go back to the controller and continue on our unfinished ports. So while I'm writing this, let's have a look at the model again, the system model that we made earlier, to see what more kind of ports we need to have. And we can see that we are doing the 2 receiver ports now, but we also need to provide a ports, which is the dial LED left and right. And then we shall add the client ports as well. But we still haven't made the interfaces for all of these, so we need to do that before we can continue. Heading back to the interfaces SWCs, we will now continue with the next sender receiver interface. We shall call this dial LED if. And once again, we will use the enumeration data type that we defined earlier. So these 2 interfaces will thus pretty much look the same, and we could have used only one interface for both. But in this case, I create 2 with 2 specific names, so that the application model will be more clear in the end. The last interface we need to define is the client-server interface, and I will name it heating element if. This kind of interface works with operations instead of data, and I will use the code completion to create an operation template which speeds things up a little bit. For this interface, we only need incoming commands to the server, so we choose in, and again we will work with our enumeration data type. Having all of the interfaces now, we can actually finish our heating controller finally. So let's go back there and add all of the ports. So we have the dial left, which provides the dial LED interface. And then we have dial LED right, which uses the same interface, of course. And lastly, we have two clients for the heating elements, left and right. And both, of course, use the heating element if interface. However, we are not completely finished with our heating controller yet, as we need to add some internal behavior to it. Once again, I use here a code completion and a template, which is the internal behavior template. We will call this internal behavior set heating behavior. And this is very specific for our application. So with code completion, you here get the suggestion to use the heating controller type. What we have to do is add a runnable, and also here again I use a template to speed things up. And what we will need is data read access for the to receive reports. We will need data write access for the two sender ports. The wildcard at the end means that we can access all of the data elements that are defined in the interface. And lastly, you need two server call points for the client ports. The last thing we have to add is an implementation, which is something that each internal behavior has to have. This is explained more in the Autosar specification, which is called software component template. And I will do a simple setup here. If you want to read some more about it, then please do so in this specification. And with that, we are finished with our heating controller, so we will continue with our other applications. We'll do this by right-clicking in the navigator, choosing New, Other, and again Artext SWCD file. And what we'll do next is the heating dial, which we will put in the package tutorial LED dial. Let's open up the SWCD and start to create our component application, which we will call LED dial type. And as I mentioned earlier, we will only have to make one of these, even though we have one left and one right, because in the model this is the same kind of entity. The distinguishment between left and right will be made when the SWC is actually instantiated. And unfortunately, we don't have time to do that in this tutorial, but we will do that in the next. So let's add the receiver port LED, and even though in the model it says that we have another port as well, the IO, we will not do it today, we will do it later in another tutorial. And then as before, we need to make an internal behavior, which we call heating dial behavior, and declare for which application it's for. And then we add a runnable, just as before, which we call dial main. And in the runnable we declare what kind of access the port has. And since it's a receiver, we have data read access. And lastly, we add the implementation for the behavior. And with that, our heating dial is finished. And the last thing we have to add now is the seat heating element. So just as before, New, Other, Artext SWCs file, and we will call this heating element. And we'll put it in the package tutorial heating element. I will explain this about the package a little bit more further on. But for now we will open the heating element SWCs, and just as in earlier steps we start with creating a component application, which we will call heating element type. And declare the port. It also has one port. We will ignore the IO also here. And this is a server port, which we will call heating command, that provides the heating element interface. Then we add an internal behavior for the application heating element type, which we will call heating element behavior. And next we add a runnable, which we call set heating command. And since this is a server, we will have an operation invoked event in this runnable. And as usual, we need to add an implementation for the internal behavior. We call this heating element implementation, which will be for the heating element behavior. And with that, we are now finished with configuring our model. But before ending this tutorial, I would want to give you some tips on how to navigate the model. You might have noticed that in the Autosar navigator we have something that is called the merge model. When we expand it, we can see the tutorial package that we have put our applications into. Or rather, it shows here in the model since we defined our packages this way in the SWCs. Here we can see everything that we have done collected in one place. If we compare the heating controller in the merge model and in the SWCD by expanding it the same way, we see that everything is identical. So the merge model is thus not a file, but merely a visualization of the whole model that we are working with. It gives us an effective overview. If we would have referenced other projects, their additions to the model would also be visible here. I would like to show you one last interesting thing in our model, and that is the enumeration that we defined earlier in the interfaces SWCs file. We can see that Artext has generated all necessary model elements that are required to make a new data implementation type. If we would have wanted to use regular data types such as booleans or integers, also these need to be defined first. Since ArcCore already includes most common definitions, one trick is to copy the RxML from core to your project, or by referencing the core project directly, which would result in the model elements in ArcCore to be available in your own project. So today we have made the system model. We have created software components. And the next step will be to connect these components and to instantiate them in ECU extracts. I thank you for your time and hope that you will join me in the next tutorial. For more information, please visit our website at arccore.com.